Hi everyone, welcome to Moscan. So in today's video, we have taken one question which is based on the current mirror circuit. You can see one circuit is drawn here. M1, M2, M3, M4, these four PMOSes are forming current mirror, and similarly M5, M6, M7, these three NMOSes are also forming current mirror. I reference is given to us which is equal to 2 milliampere. One load resistance is given to us whose value is 2 kilo ohm, and we need to find out the current flowing from each branch denoted as I1, I2, and the load current which is flowing from load resistance is denoted as I3, and we also need to calculate V0. So once we will get the I3, it's become very easier for us to calculate V0 because IR into V need to do only. So let's start solving this question. This is very interesting question and you will get to know about one very good concept of current mirror in the circuit. So make sure you watch till the end. So let's start from here itself. You can see this MOS M1 and M2 are forming current mirror, these two PMOSes. So we know in current mirror if we have to calculate the output current, so we should know the reference current, we should know the W by L of output branch and W by L of reference branch, then we can calculate the output current. So formula of calculating output current, which is here I1, is equal to W by L of output branch, and which is for MOS M2 here, and W by L of a reference branch, which is MOS M1 here, into I reference. Now we know W by L of MOS M2 is given as 5 times W by L. W by L of reference branch is W by L only, and I reference is given to us as 2 milliampere. So we will get output current I1 is equal to 10 milliampere. So this current is known to us. Now this current will flow to this NMOS also from MOS M5. So the similar order of current will flow here also in M5. So in entire branch, current flow will be equal to 10 milliampere. Now here current calculation becomes interesting because if you see here, M2, M3 are also forming current mirror, PMOS, these two PMOS, and M6, M5, M6, these two NMOSes are also forming current mirror. So we have to calculate the output current based on this current mirror also and based on this PMOS current mirror also. And then we will be able to figure out how much current is actually flowing in this branch. So let's start the calculation. Let's first calculate for these M2, M3 PMOS which are forming current mirror here. So like this calculation only, if I have to calculate this current from I2 from because of PMOSes, which I am denoting as I2P. So W by L of this M3 MOS is given to us 6 into W by L divided by 5 into W by L. We could also have taken W by L instead of 5W by L because this is the reference branch which is generating VGS reference current, and these all are output branches. So ideally we should take division factor as reference branch from where the current is getting generated. But since here current calculation is fine, so we are taking 5W by L only, but this concept will come into picture later on. So that's why I am telling you here only. And I reference would be equal to 10 milliampere. That's what we have calculated. So if we calculate here, we will get 12 milliampere. So because of PMOS, current should ideally flow 12 milliampere. But now we also need to calculate the current because of this NMOS, and then only we will be able to know how much current is actually flowing because of this I2. So let's calculate I2 because of NMOS. So again, W by L of this NMOS is 4 into W by L divided by W by L of this MOS M5 into I reference, which is 10 milliampere. Here we are getting 8 milliampere. So now you see this PMOS is trying to flow 12 milliampere of current, but this NMOS is only capable of supporting 8 milliampere current. So this is the kind of a minimum current selector current mirror where if PMOS is trying to support 12 milliampere and NMOS is only able to support 8 milliampere, so the final output current would be the minimum of what PMOS and NMOS is supporting. So if we take the minimum of 12 milliampere and 8 milliampere, so output current I2 would be equal to 8 milliampere because that's what the minimum is, right? So this was an important concept. Sometimes in interview you might be asked question based on this concept only, so that's why I explained it clearly. Now let's talk about the third branch current. So similarly, the way we have calculated for this middle branch, the same approach we will use for this final branch current calculation also. So for M4, we have to calculate the output current. But as I mentioned before, now if you see here, current ideally should have flown 12 milliampere, but because of the current supported in NMOS, we are calculating it as equal to 8 milliampere. So this branch is not having the exact current which we calculated. So when we will calculate the current for M4, let's denote is at I4. So I4, because of PMOS, will be equal to 4 times W by L of output branch. Now W by L of reference branch, we will not take this one because this is output current and being determined by NMOS, PMOS current flow and all. We will rather take this W by L, which is the reference MOSFET. Right, so W by L and I reference also we will take as 2 milliampere here, which is the reference current. So we will get, because of PMOS, the current in this final branch is 8 milliampere. Now we also need to calculate how much current is flowing because of this NMOS, and then we will be able to figure out how much current is actually flowing in this branch and how much is going in this resistor. So I4, because of NMOS, if I have to calculate, so 3 into W by L is the output W by L, whereas 5 into W by L is the reference W by L for this NMOS current mirror. This is the reference NMOS current mirror. Into I reference would be 10 milliampere because current mirror for NMOS is starting from here itself, right? So if I calculate the current here, it is coming 6 milliampere. So now you see 8 milliampere is starting to flow from here. 6 milliampere is going in this NMOS. So remaining 2 will go in this load resistance, right? If this load resistance would not have been there, so final current would have been in this branch equal to 6 milliampere. But since there is load resistance also, the remaining 2 will go in this load resistance. So I3 current is equal to 2 milliampere, which was asked in this question. I2 is 8 milliampere and I1 is 10 milliampere, which we have calculated. Now V0 easily we can calculate. V0 would be equal to I3 into R. I3 we have calculated 2 milliampere and R value is given to us equal to 2 kilo ohm. So V0 will be equal to 4 volt. That's what we will get here. So this was an important question because here minimum current selector concept was also involved and how the current is being distributed in multiple branches was also involved. So that's why it was an important question. I hope you might have learned something new from this video. If you found this video useful, please share with your friends. And if you haven't subscribed our channel, please do subscribe.